All right, here are the notes for Unit 3A, Uses and Abuses of Percentages. There are three ways of using percentages. First of all, we can use them as fractions. For example, a total of 13,000 newspaper employees, 2.6% of the newspaper force lost their jobs. We can use it to describe a change. Citigroup stock fell 15% last week to $44.25. Then you can use it for comparisons. The advanced battery lasts 125% longer than the standard one, but costs 200 times more. So when asked, the three ways of using percentages is we can use them as fractions, to describe change, or for comparison. And comparison is always you're listing two things together to show the advanced battery lasts longer than the standard one. And when you describe change, notice it fell 15% or it can rise 15%. And as fractions, you're talking about the percentages of the employees here. All right, let's do an example. A presidential survey. An opinion poll found that 35% of 1,069 people surveyed said that the president is doing a good job. How many said the president is doing a good job? So now we're going to try to figure out how many people that 35% represents. Because of indicates multiplication, you're going to have 35% of the 1,069 respondents. The first thing you need to remember is when you change a percent to a decimal, you always start where the decimal is understood. Since this says 35, the decimal is understood to be to the far right, and you have to move it 2 times over to make it a decimal. So we would move the decimal in front of the 5 and then in front of the 3. So 35% is the same as 0.35. So we're going to take 0.35 and multiply it times 1,069. So approximately you're going to get 374.15. So we're talking about people. You can't have a 0.15 people. So we're going to round it approximately 374. Now, this is where you have to make sure you're doing it correctly by seeing if it makes sense. So when we're talking about 35% of 1,069 people, 35% is going to be less because this is the total and this is only going to be part of it. So when we go back and look, is 374 less than the total? It is when you look at that. So about 374 people said the president is doing a good job. We rounded the number to 374 to obtain a whole number because of what we're talking about, which is people. Remember what your units are. Absolute and relative change. The absolute change describes the actual increase or decrease from a reference value or your starting number to the new value. So the formula would be something you need to have in your notes. Absolute change equals new value minus the reference value. Relative change is a fraction that describes the size of the absolute change in comparison to the reference value. This is going to give you a percentage, the percentage of the change. So relative change is you take the new value, you subtract the reference value, and then you divide that answer by the reference value, and then you multiply it by 100%. Well, so let's do an example. All right, stock rise prices. During a 6-month period, Lunar Industries stock doubled in price from $7 to $14. What were the absolute and the relative changes in the stock price? Okay, so when we look at it, absolute change, if you remember, is new value minus reference value. So our new value is 14, and it changed from 7. So 14 minus 7 is $7. So our absolute change was $7. And it's a positive, so it was an increase. Relative change, if you remember, is new value minus reference value. If you look, that's absolute change. So you already have that answer for the top. And then you divide it by reference value and you multiply it times 100. So 14 minus 7 was 7. 7 divided by 7 is 1 times 100% is 100%. Okay. Depreciating a computer. How much is your computer worth after it's depreciated. You bought a new laptop computer 3 years ago for $1,000. Today, it's worth only $300. Describe the absolute and the relative change in the laptop's value. Well, first of all, did it go up or down? Did it increase or decrease? So it started at 1,000 and it is now 300, so it was a decrease. So the reference value is the original price of 1,000 and the new value is the current worth, which is 300. So the absolute change would be the 300 minus the 1,000. So if you look at it, it's negative 700, which means it's a depreciation or a loss of 700. The negative sign tells us that the computer's worth is 700 less than the price you paid 3 years ago. The relative change is the new value minus the reference value divided by the reference value. So 300 minus 1,000 divided by 1,000 gives you negative 70%. So it was a decrease of 70% from the worth it was valued at 3 years ago. Relative, absolute, and relative difference. The absolute difference is the actual difference between the compared value and the reference value. So the formula for absolute difference, make sure that you write this and title it organized in your notes. Absolute difference is compared value minus reference value. Relative difference describes the size of the absolute difference as a fraction of the reference value. So relative difference is absolute difference, which means the compared value minus the reference value, divided by the reference value. Now, I know you see this 100% out here. If you're going to multiply by 100%, you have to make it a decimal. Remember that that is multiplied by 1 because 100% is 1. So let's do an example. Income comparison. Recent data showed that California ranked first among the 50 states in average income at about $68,900 per person. And West Virginia ranked last at $46,600 per person. You've got 2 questions to answer. A, how much lower is the average income in West Virginia than California? How much higher is the average income in California than in West Virginia? Answer both questions in terms of absolute and relative terms. So you're going to have 2 answers for each one. So in A, your absolute difference is your compared value to your reference value. 46,600 minus 68,900 would give you a negative 22,300. The relative difference is your compared value minus your reference value divided by your reference value. So you get the negative 22,300 and you have to divide that by the 68,900. So you get a negative 32.4%. The negative sign tells us that the average income in West Virginia is less than that in California by 22,300, or if you do the relative, it's by 32.4%. So you have your absolute, which is given in the value, and then you have your relative, which is given in the percentage of the difference. B, this time West Virginia follows than, so we use West Virginia's income as the reference and California as the compared. All right, so it's all in the wording when you're looking at the one you reference to what you're comparing it to. So we're going to switch them around this time. So absolute difference is your compared, your reference. So we're going to take the California, which is 68,900, minus the 46,600, and you get 22,300. The relative difference is the compared value minus the reference value divided by the reference value, which gave you the 22,300, and you're going to divide that by the 46,600. So you get a negative 47.9%. Average income in California, that should actually be a positive. That is a typo. Excuse that right there. That should be a positive 47.9%. So when you put this in words of what it means, average income in California is more than that in West Virginia by 22,300. That's why it was positive. Or it was more by 47.9%. Remember, the actual units is your absolute, and the relative is always in a percentage. of versus more than or less than. If the new or compared value is p% more than the reference value, p just being the value, then it is 100 plus the p of the reference value. If the new or compared value is p% less than the reference value, then you're going to take 100 and minus p to get the percentage of the reference value. Okay? For example, this is what we're going to use, what they just said. Income differences. Carol earns 200% more than William. What is Carol's income as a percentage of William's? How many times as large as William's income is Carol's? All right, so we're going to use the rule of p% more than, all right, because she is 200% more than William. So that's going to be the 100 plus p%. Because Carol's income is 200% more than William's, we set p equal to 200. Therefore, Carol's income is 100 plus 200, which is 300% of William's income. Because 300%, when you change it to decimal, remember, the decimal is the farthest to the right, and you move it 2, that would be 3. That means Carol earns 3 times as much as William. Does that make sense? Are you following me? Because when it says 200% more than William here, they want you to know what the percentage is. So you've already got the 100% if they're equal, and she's 200% more. So she actually makes 300% of William's income when you compare it. So that means she makes 3 times as much as him. All right. In this example, they're talking about a sale. A store is having 25% off sale. How does an item's sale price compare to its original price? 25% off means that the item is going to be 25% less than the original price. So you would use the formula of the 100 minus the p, which is 25. So it's 75% of the original price. For example, if the original price was $100, and since you get 25% off of that, the sale price is going to be $75. Percentages of percentages. When a change or difference is expressed in percentage points, assume it is an absolute change or difference when they're talking about it. With the percent sign or the word percent, it is a relative change or difference. So when you're reading these problems, when you look at percentage points, always use your absolute. When you look and you have either this sign behind it and it's already as a percentage, or the word percent is used, it is a relative change. So that's how you know which formula to use. For example, if a bank increases its interest rate from 3% to 4%, the interest rate is increased by 1 percentage point. All right. Well, if you look here, they're using the symbols for percentage here. So that means you're looking at relative change. All right. So it increased from 3 to 4. So that would be 4% minus 3 over 3% times that. So it's a 33% change. Solving percentage problems. All right. If the compared value of p%, whatever they give you as your percentage, is more than the reference value, then the compared value is 100 plus p times the reference value. And the reference value is always found by the compared value divided by 100 plus p. If the compared value is less than the reference value, then you're going to use the 100 minus instead of the 100 plus in all of the same formulas. So it'll be 100 instead of here where you have compared value, instead of the plus you would have 100 minus, and then here it would be divided by the 100 minus. That's if it is less than the reference value. For example, let's do some tax calculations. You purchase a shirt with a labeled pre-tax price of $21. The local sales tax is 6%. What is your final cost, meaning including tax? So your final cost is going to be what it is labeled plus the 6% of the labeled price. So this is going to be more than the reference price. So that's going to be 100 plus 6 times the labeled price. That's 106% times 21 equals $1.06 times 21. That should be plus 21. Excuse me. That should not be a times there. That should be a plus. So when you add the label price and the tax that you're going to have onto it, then you're going to have $22.26. So that would be the final cost of the shirt because you added the label and the taxes. Abuses of percentages. Beware of shifting reference values. A 10% pay cut is followed by a 10% pay raise. Less than nothing. Decrease caloric intake by 150% to lose weight. Think about that. You're taking in, let's say you're taking in 2,000 calories. They want you to decrease your caloric intake by 150%. Can you go less calories than what you're taking in? Can you go negative calories? Don't average percentages. If 70% of the boys and 60% of the girls in the class voted to go to a water park, then 65% of the students in the class voted to go to the water park. That is not how you find your percentages of the total class. Do not take what they have, add them together, and divide by the 2. All right, this is an example, shifting investment values. A stockbroker offers the following defense to angry investors. I admit that the value of your investments fell 60% during my first year on the job. This year, however, their value has increased by 75%, so you are now 15% ahead. Evaluate this. Does this make sense? Imagine you began with an investment of $1,000. During the first year, your investment lost 60% of its value, or $600, leaving you with only $400. During the second year, your investment gained 75% of that 400, not of the 1,000, of the 400 of what was there. So then you would take 75%, which is 0.75 of 400, and that equals 300. So you would take your 400 and add your 300. Therefore, at the end of the second year, your investment now is worth $700, which is still less than your original investment of $1,000, and certainly not a 15% gain overall. We can trace the problem with the stockholder's defense to a shifting reference value. It was 1,000 for the first calculation and 400 for the second. So this is what we would call a shifting reference value. The next one, impossible sell. The store advertises that it will take 150% off of the price of all merchandise. What should happen when you go to check out to buy a $500 item? For example, your solution would be if the price were 100% off, then it would be free, correct? So if the price is 150% off, then the store would pay you to actually come in and buy it half of what it was. So more than likely, the store manager doesn't understand percentages if he expects to pay you to come in and get these items. All right, batting averages. In baseball, a player's batting average represents the percentage of at-bats in which he got a hit. So it's how many times he actually comes up to bat, and out of those, how many he hits. For example, a batting average of .350 means that the player got a hit 35% of the time he batted. Suppose a player had a batting average of .2 during the first half of the season and .4 during the second half of the season. Can we conclude that his batting average for the entire season is .3? That would be averaging the two given together. Why or why not? Give an example that illustrates your reasoning. Of course not. We said you cannot average given percentages. For example, suppose that he had 300 at-bats during the first half of the season and 200 at-bats at the second half, for a total of 500 at-bats. His first half of batting average, .2, means that he got 20% of his hits out of 300. So if we were trying to find out how many hits that actually was, you take the .2 and multiply it by the 300, which means he only got 60 hits. His second half batting average of .4 means that he got 40% of his 200 at-bats, which means he got 80%. For the season, that means he got the 60 plus the 80, which is 140, out of his total 500. So his season average is 140 out of the 500, which is 28%, or 0.28, not 0.30, found by averaging his first and second half together. In fact, the only case in which his season average would be 3.0 is if he had precisely the same number of bats in each half of the season. It has to be equal on both of them.